Hi everyone. Now in this session we will discuss some numerical questions from stoichiometry as well as states of matter. See, let us do the first one. Find out the number of gram atoms in 6.4 grams of helium. Suppose if this is the question given, immediately students will go to this word grams. So they thought of finding something in grams, but the point is not like that. See, here one has to remember that number of gram atoms is nothing but number of moles of atoms. Number of gram atoms is nothing but number of moles of atoms. Nothing but means 1 gram atom is nothing but 1 mole of atom. 1 gram atom is nothing but 1 mole of atom, means 1 gram atom is nothing but Avogadro number of atoms. Avogadro number of atoms. So using this logic, we have to solve this numerical. Now what is asked here? Find out number of gram atoms, means find out number of moles of helium atoms. You know, small n is the symbol for number of moles. Number of moles of helium atom can be calculated as mass by molar mass. So mass is 6.4 and molar mass of helium, as it is an atom, we have to take gram atomic mass, it is 4 grams, it is 1.6. So number of moles of helium is nothing but 1.6, which is also called as the number of gram atoms of helium. Okay, so this is one question of this model. Now let us see one more question of this type. Suppose this is another question given. Calculate number of molecules, number of gram molecules in 1.6 grams of methane. The same way as we did the previous question, number of gram molecules is nothing but number of moles of molecules. Number of gram molecules is nothing but number of moles of molecules, means 1 gram molecule is nothing but 1 mole of molecule. 1 gram molecule is nothing but 1 mole of molecule, means Avogadro number of molecules. That means Avogadro number of molecules. Okay, see now here we are asked with the number of gram molecules, means number of moles of molecule. Which molecule? Whose molecules? Number of moles of methane molecule is mass by molar mass. Mass is given as 1.6 and molar mass of methane is 16. It is 0.1 gram molecule. See, sometimes they will give a molecule but ask us to find number of atoms. They will give a molecule but ask us to find out number of atoms. Okay, so we have to use the relation number of atoms in n moles of molecules. Number of atoms in n moles of molecules can be calculated as number of moles of molecules into Avogadro number into atomicity. So how do you find number of atoms in certain number of moles of molecules? Given number of moles of molecules into Avogadro number into atomicity. What's meant by the term atomicity? Atomicity is nothing but the total number of atoms present in one molecule of a substance. Total number of atoms present in one molecule of a substance. So now here number of moles, how do you find? Mass by molar mass into Avogadro number into atomicity. So given mass is 8, molar mass of oxygen is 32 into Avogadro number into atomicity of oxygen, means one molecule of oxygen has how many atoms? One molecule of oxygen has 2 atoms into 2. So it is 16 twos. So 0.5 into Avogadro number of atoms. So in this way, so what are the relations we did earlier? Number of atoms we calculated as number of moles of atoms into Avogadro number. Number of molecules we calculated as number of moles of molecules into Avogadro number. But number of atoms in number of moles of molecules, they will give molecules but ask us to find out number of atoms. This can be calculated as number of moles of molecules into Avogadro number into atomicity. So these are the relations we have to use while solving different numericals. So this is another model of question. Calculate number of hydrogen atoms in 1.6 grams of methane. It is a molecule, see, it is a molecule and atoms. Students will focus on this, molecules are given, atoms are given. So number of atoms equals to number of moles of molecules into Avogadro number into atomicity. Immediately students will go to this relation, but this is not useful here. If the question is only to find out number of atoms, if the question is to find out the number of atoms in so and so, then it is valid. But here it is asking about number of hydrogen atoms. So instead of atomicity, what we have to do? We have to take number of hydrogens in one molecule of a substance. Number of hydrogens in one molecule of a substance we have to take. So for this given question, number of hydrogen atoms can be calculated as number of moles of methane. How do you find number of moles? Mass of methane over molar mass of methane into Avogadro number into number of hydrogens per molecule of methane is 4. So this is equals to 1.6 by 16 into Avogadro number into 4. So we have to simplify this. It is 0.1 into 4, 0.4 into Avogadro number of hydrogen atoms. Okay, this is one model question. At the same time, we will solve a different numerical where there is more scope for students to get confused. See, suppose we are given with a question to find out number of molecules of H2O in 18 ml water. See, if the question is calculate number of water molecules in 18 ml water at STP. If the question is given like to find out number of water molecules in 18 ml of water at STP. STP conditions, there are two ways actually. Old STP conditions as well as new STP conditions. Old STP as well as new STP. Old STP conditions are 0 degrees Celsius and 1 atmospheric pressure. 0 degrees Celsius and 1 atmospheric pressure. Whereas new STP conditions given by IUPAC are 0 degrees Celsius and 1 bar pressure. 0 degrees Celsius and 1 bar pressure. And accordingly, molar volume also varies. If it is according to old STP conditions, which is 0 degrees and 1 atmospheric pressure, molar volume will be 22.414 liters. Okay, but if it is according to new IUPAC STP conditions, molar volume will be 22.67 liters, usually which is taken as 22.7 liters. So by observing the values given in the options, you can choose which method they are following or which STP conditions they are following. Usually, as it is examinations are based on NCERT textbook, they follow 22.7 liters thing. Okay, now let us solve this question. Right? See, calculate number of water molecules in 18 ml of water. So we know that 1 mole has Avogadro number of molecules, right? 1 mole has Avogadro number of molecules. Then 18 ml is equal to how many moles? Immediately we have to go to this point. See, we need to remember that density of water is 1 gram per 1 ml. What's meant by this? 1 ml weighs 1 gram. It means 1 ml weighs 1 gram. Then 18 ml weighs how many grams? 18 ml weighs 18 grams. 18 ml weighs 18 grams. So this is the mass of water. This is the mass of water. Then number of moles of water can be calculated as 18 mass over molar mass. It is 1 mole. 1 mole at STP contains how many number of molecules? Avogadro number of molecules. So this will be the answer. So while solving the question, we have to remember and apply so many cases, right? Yes. Now let us discuss some questions on equivalent mass. So this is another area where usually students neglect. Okay, equivalent mass of a substance. Equivalent mass of a substance is the amount of substance that can react with or replace. What amount of substance can react with or replace either 1 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine. So this is the basic definition for equivalent mass. So what's meant by equivalent mass of a substance? The amount of substance that can react with or replace either 1 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine. Now let us solve some examples related to this one. For example, sodium is reacting with HCl to give NaCl plus half H2. See, in this reaction what happened? Some amount of sodium displaced some mass of hydrogen. Some mass of sodium displaced some mass of hydrogen. See, what mass of hydrogen is displaced by what mass of sodium? Tell me. 1 gram of hydrogen was displaced by 23 grams of sodium. So this amount of substance which can replace 1 gram of hydrogen is said to be its equivalent mass. So as per the definition, equivalent mass of sodium is 23 because this is the mass of sodium that is replacing 1 gram of hydrogen. Let us take one more question. NaH. In this example, what mass of sodium is reacting with what mass of hydrogen? See, what mass of sodium reacted with what mass of hydrogen? 23 grams combined with 1 gram of hydrogen. According to the definition, the amount of substance that can react with 1 gram of hydrogen is said to be its equivalent mass. As 23 combined with 1 gram of hydrogen, equivalent mass of sodium is given as 23. Like this, we may get some questions on equivalent mass concept also. Okay, for example, a simple question we will do. See, let us solve this question which is based on equivalent mass, right? 1 gram of a substance or 1 gram of a metal. Let us take 1 gram of a metal, that is better. 1 gram of a metal replaced 0.05 grams of hydrogen. Then find its equivalent mass. So this is one basic model question, right? As per the definition, what amount is replacing 1 gram of hydrogen? That is said to be its equivalent mass. So what mass of metal is replacing 1 gram of hydrogen? That's what we have to find. See, 0.05 grams hydrogen was replaced by 1 gram of metal. 0.05 grams hydrogen was replaced by 1 gram of metal. Then 1 gram of hydrogen will be replaced by how many grams of metal? So you have to use a crisscross method. 1 into 1 by 0.05. So it is 1 by 20 means 20 grams is the equivalent mass of metal. So in this way, sometimes we may be asked with the equivalent mass question, right? So this is another model of question in equivalent mass concept. See, calculate equivalent mass of Na2S2O3, sodium thiosulfate, which is called as, its hydrated form .5H2 is called as hypo. Equivalent mass of sodium thiosulfate in the given reaction. So whenever such questions are given, we have to depend on oxidation number concept. You are well studied with this oxidation number concept, right? Find the oxidation number of sulfur here, iodine here. Iodine is not required because we are asked to find out equivalent mass of sodium thiosulfate. So that is not at all required. So here 2x plus 1 into 2 plus 2 minus 6 equals to 0. X is equals to plus 2. Right? Here each sulfur is in plus 2 oxidation state. Right? When it comes here, it is 4 sulfur. 4x plus 2 minus 12 equals to 0. X equals to 2.5. So, oxidation number of each sulfur is changing from plus 2 to 2.5. So, for one sulfur, difference in oxidation state is 0.5. But we have to see the difference for two sulfur atoms. Why? Because equivalent mass of 1 mole of sodium thiosulfate is asked. In 1 mole of sodium thiosulfate, as 2 sulfur atoms are there, we need to find the difference for 2 sulfur atoms. Once again, for 1 sulfur atom, the difference in the oxidation state is 0.5. For 2 sulfur atoms, the difference can be given as 1. So this is called as valency factor. This is called as valency factor. You know, valency factor of acids is nothing but basicity. Valency factor of base is nothing but acidity. And valency factor of a salt is nothing but either total positive charges or negative charges. And valency factor of oxidizing and reducing agents is difference in oxidation state per mole. Now here valency factor is 1. Equivalent mass of Na2S2O3 is nothing but molar mass of Na2S2O3 over its valency factor. So let it be M by valency factor is 1. This is another numerical in equivalent mass concept. Right? So this is another question from equivalent mass concept. Given 0.2 grams of a metal combined with 0.355 grams of chlorine, then find equivalent mass of metal. As per the definition, what we have studied in the definition, the amount of substance that can react with or replace either 1 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine is said to be its equivalent mass. We studied in the previous slide. Right. Now, 0.2 grams of metal M reacted with 0.355 grams of chlorine. When 0.355 grams chlorine combined with 0.2 grams of metal, then 35.5 grams of chlorine will be combining with how many grams of metal? So we have to find this, which stands for one equivalent mass of metal. So using crisscross technique, 35.5 into 0.2 by 0.355. This will be cancelled by 100 times. So it is 20 grams. So equivalent mass of metal here in this question is 20 grams. In this way, we can solve some numericals on equivalent mass. Right? This is another question, another concept, that is calculations based on mass-mass relations or mass-volume relations or volume-volume relations. Now you see 1 gram of mixture of sodium carbonate and magnesium carbonate on heating liberated 56 ml of CO2. 1 gram of total mixture contains sodium carbonate as well as magnesium carbonate. On heating liberated 56 ml of carbon dioxide. Calculate percent by mass of sodium carbonate in that 1 gram sample. So we are given with a mixture which contains sodium carbonate and magnesium carbonate. Which contains sodium carbonate and magnesium carbonate. Total mass is 1 gram. Immediately students will go to the corresponding equations. They will write MgCO3 on thermal decomposition gives MgO plus CO2. This is correct. But some students will go to this equation also. Na2CO3 on thermal decomposition giving Na2O plus CO2. There they do a mistake. So we have to remember the point. This is a wrong line. So we studied in alkali metals, alkali metal carbonates except lithium carbonate are thermally highly stable and do not decompose. Down the group their stability, thermal stability increases. So in this mixture, out of sodium carbonate and magnesium carbonate, the one that decomposes readily is only magnesium carbonate, not sodium carbonate. Understood? So the second equation is not possible. This reaction is not possible. So whatever the carbon dioxide obtained in this thermal decomposition, that is purely obtained from magnesium carbonate only. Right? Now as per the equation, what is the molar mass or formula mass of MgCO3? It is 84 grams. On thermal decomposition is liberating 1 mole of CO2 at STP occupy, suppose 22.4 liters volume. We are following suppose old STP conditions time being, 22.4 liters. Then means 22,400 ml, 22,400 ml. Then 56 ml CO2 will be obtained from how many grams? Immediately we have to find out this value. Then 56 ml of CO2 will be obtained from how many grams of magnesium carbonate? Crisscross the thing. 56 into 84 by 22,400. On simplification, you will get it as 0.21 grams, I think. So out of this total 1 gram sample, magnesium carbonate is 0.21 and the rest 0.79 grams is sodium carbonate. Out of 1 gram, 0.79 grams is sodium carbonate. Therefore, percentage of sodium carbonate can be calculated as 0.79 out of total 1 mass into 100. It is 79%. So, right sir? This is another question based on calculations on mass and mass volume relation. Suppose we are asked like this. Calculate the volume of CO2 liberated by 10 grams of 90% pure limestone, 90% by mass pure limestone. So usually we can go to the equation CaCO3 giving rise to CaO plus CO2. Now in this question we are dealing with volume of CO2 and mass of CaCO3. So this is a question based on mass volume relation. Now as per the equation, it should be completely balanced of course. As per equation, at STP conditions, you notice what mass is giving what volume. 100 grams, which is the formula mass of CaCO3. 100 grams of CaCO3 is giving 1 mole at STP occupies 22.4 liters. Suppose we are using this for the sake of easy calculations, or you can take even 22.7 liters. Usually we have to consider 22.7 liters. Don't neglect that point. 100 grams of CaCO3 at STP is liberating 22.4 liters of CO2. This then 10 grams of CaCO3 will liberate 2.24 liters carbon dioxide. 2.24 liters carbon dioxide, right? Now, this is the actual procedure and this will be the answer when 10 out of 10 is the purity. When in 10 grams of CaCO3, total 10 grams itself is CaCO3 only, then this will be the answer. But in our question, it's given 90% pure, means out of 10 grams of CaCO3, only 90% is CaCO3. Rest 10 grams is other than CaCO3, which can be treated as impurity. So, when 10 grams is giving 20.24 liters of CO2, then 9 grams of CaCO3, which is 90% mass of this value, 9 grams of CaCO3 will give how many liters of SO2? How? Using crisscross method, 9 into 2.24 by 10. So we will get some value, so many liters of CO2. Right? Means out of this 2.24, we have to subtract, out of this 2.24, we have to subtract 0.224. We have to subtract 0.224. Means this is a 6 and this is 1, this is 0, 2.016 approximately. So calculation part depends on person to person, it varies, right? So this is how we can calculate the volume of CO2 in less than 100% purity, right? See, this is another question. 1 mole of N2H4 hydrazine had lost 10 moles of electrons. Then calculate oxidation state of nitrogen if the rest of the atoms are not involved in this change. On this condition only, this question can be solved. If that condition is not specified, method will be different. Right? So N2H4, hydrazine N2H4 had lost 10 moles of electrons. 10 moles of electrons. Then here 10 plus charges will be displayed out. Right? 10 plus charges, because the 10 minus charges are, till now 10 minus charges are compensating 10 plus charges. Now those 10 minus charges moved out, so they will be left as uncancelled. Right? So this is the species left when 1 mole of hydrogen lost 10 moles of electrons. Then find the oxidation state of nitrogen. 2x plus 4 is equals to plus 10, 2x is equal to plus 6, x is equals to plus 3. So this sort of numericals also will be asked. Right? Let us see one more question based on these relations. See, let us discuss some more numericals based on this oxidation state. Suppose if they ask us to find oxidation state of chlorine in bleaching powder. Find the oxidation state of chlorine in bleaching powder. So immediately we have to go to the concept of bleaching powder. Bleaching powder is usually given as CaOCl2. Okay, so there may be a misconception, like if you find it directly you will get it as 0. If you find the oxidation state of chlorine directly you will get it as 0. But 0 won't be given in the options. Understood? That's why we have to remember the term that bleaching powder is a combination of, it is a mixed salt of calcium chloride and calcium hypochlorite. Bleaching powder is a mixed salt of calcium chloride and calcium hypochlorite, means CaCl2 and CaOCl taken twice. So combination of these two is called as bleaching powder. Now from CaCl2 we are getting Ca2 plus 2 Cl minus ions, where each chlorine is bearing -1 oxidation state. And from calcium hypochlorite, CaOCl taken twice on dissociation giving OCl -1. Let us find the oxidation number of chlorine in this. So x minus 2 equals to -1, x is equals to +1. In this way, the oxidation states of chlorine in bleaching powder are +1, -1 respectively. So there are so many questions of this type. Okay, let us take one more question. See, this is one more question based on oxidation states. Calculate oxidation state of bromine in Br3O8. Immediately students will go to this concept, Br3O8. 3x minus 16 equals to 0, x is equals to plus 16 by 3. Plus 16 by 3. So using this concept they try to solve the question. 8 plus 0 plus 8, 16 by 3 bromine atoms, 16 by 3. 14 plus 2, 16 by 3. 10 plus 6, 16 by 3. 6, 4, 6, 12 plus 4, 16 by 3. So all options are matching with this method. So this is an average oxidation state, and all the 4 options are suitable for that average oxidation state. In such a case, what we have to do? We have to go for its exact structure. So this is the structure of Br3O8. Now, so many bonds with electronegative atoms, that many plus charges atom is going to get. I am repeating, so many bonds with electronegative atoms, more electronegative atoms, that many plus charges bromine is going to get. Okay. Now, bromine and oxygen, which is more electronegative? Oxygen is more electronegative. How many bonds are with oxygen? 1, 2, 3, 4, 5, 6. So many bonds with more electronegative atoms, that many positive charges it will get. So 1, 2, 3, 4, 5, 6. Bromine is getting plus 6. Bromine and bromine both are of same electronegativity. That's why this bond cannot be polarized. Again, the central bromine is 1, 2, 3, 4. It is getting plus 4 oxidation state. Similarly, this one 1, 2, 3, 4, 5, 6 plus 6. So the oxidation states of bromine in the given molecule is plus 6 or R, plus 6, plus 4 and plus 6. So which option? This is the option. So this is the method to find out sometimes the individual oxidation numbers, right? Yes, now let us continue with this methods of expressing concentration. Usually when some question is given on molarity, suppose this is a question given, find molarity of 4% by volume in a OH solution. Instead of following lengthy procedure, you can use a shortcut. Whenever X% by volume of a solution is given, we can find molarity as 10 into that percent by volume by gram molecular mass. This is the shortcut we can use for solving molarity, right? Now use this formula, molarity equals to 10 into what is percent by volume, 4 by gram molecular mass of solute is 40 sodium hydroxide. It is 1 molar. Simple question. Similarly, there is one more model, that is find molarity of 9.8% by mass of H2SO4, 9.8% by mass or percent by weight, whatever it is, of H2SO4 whose density is 1.1 grams per ml. Whose density is 1.1 grams per ml. Whenever this model questions are given, if you have to follow the PU method, it will be around 8 to 9 steps and takes more than 4 minutes time. But we have to solve in competitive exams like JEE, NEET and other exams, we have to solve the question in less than half minute, for which we need some shortcut. Here the required shortcut is molarity equals to 10 into D into X by gram molecular mass, where this X is nothing but percent by mass. In this formula, X is percent by mass. Now let us substitute directly. Molarity equals to 10 into what is density given, 1.1 into X value is 9.8 by molecular mass of sulfuric acid. In sulfuric acid solution, what is solute? Sulfuric acid. So 98 its molecular mass. So it is molarity is 1.1 molar. Right. So in this way, we have to use the shortcuts to solve it in less time, to save time for the remaining questions. Understood? So let us see one more question. See, sometimes they may give a question which is based on two methods of expressing concentrations, like relation between molarity and molality. Relation between molarity and molality. And molality can be calculated as 1000 into molarity by 1000 into density minus molarity into molar mass of solute. Usually small s is for solute, capital S is for solvent. Okay, this is molecular mass of solute. In this way, for a question based on this relation between molarity and molality, density will be supplied, molality will be supplied, and molarity may be asked. Or out of 1, 2, 3, these three values, 2 will be supplied, 1 will be raised. So this is the relation we have to use for that purpose. Similarly, we have another relation between molality and mole fraction. Molality and mole fraction. We have molality as number of moles of solute into 1000 by mass of solvent in grams. Right. Multiply and divide this with the molar mass of solvent. Number of moles of solute into 1000 by mass of solvent by molar mass of solvent into molar mass of solvent. Molar mass of solvent. This ratio is nothing but mass by molar mass is nothing but number of moles of solvent. So molality can be given as number of moles of solute over number of moles of solvent into 1000 by molar mass of solvent. So using this relation, we can find molality. And if you divide and multiply this with the total number of moles, means molality equals to number of moles of solute by total moles, number of moles of solvent by total moles into 1000 by molecular mass of solvent. You know that number of moles of solute out of total moles is mole fraction of solute. Number of moles of solvent out of total moles is mole fraction of solvent. So molality can be expressed as mole fraction of solute over mole fraction of solvent into 1000 by molecular mass of solvent. So capital S is for solvent, small s is for solute. Do remember this. So these are some relations based on which